The physical system that we see around us, for example, the car. When you're designing the car, that car has to, once you sit in the car, it has to be crash safe, means you bang the car, and if you were to sit in the car, you will not get hurt. So the way people used to design cars in the past was to build a model of a car, and they actually crash tested the car, right? And I don't know if you've seen videos of a crash testing, or it's just incredible. And they put a dummy inside the car, and they measure whether the dummy will survive or not. Each crash testing costs like $2-3 million. You make a prototype of a car, you bang it. Now that you don't have to do anymore. This crash testing is done with Ansys tools called LS-DYNA. Full crash simulation, you can do thousands of simulations of a car. So without actually doing a hardware prototype, you do it through simulation. Or, I know you fly on airplanes. The Boeing airplane or Airbus airplane that you fly on, right? In the past, they used to build physical prototypes of an airplane wing, put it in a wind tunnel, and test that wing at different speeds and so on, whether the wing will lift or not. Each wind tunnel test was $10 million, right? So you do a shape of a wing, you test it, it doesn't fly or there's a drag and you fall down. Oops, mistake, $10 million down the way. You can do that through physics simulation, fluid simulation with Fluent from Ansys, right?
Yeah.
You are designing a very complicated antenna design with all these 3G, 5G, 6G antennas and so on. And it's very, very complicated to do. You don't have to do that with a physical prototype with all those 5 bars that you see on your phone. You can simulate the electromagnetics which HFS does. So the power of Ansys is all those things that people had to do with hardware prototyping, you can now do with on the computer with detailed physics simulation. Because the world around us is governed by physics, and physics doesn't lie. And we at Ansys and now at Synopsys, our solvers model those things with numerical methods, partial differential equations, with the accuracy that you don't have to do a physical testing.
Yeah.
So now what we are enabling is the reason this was a $35 billion thing. We were the leading provider of these tools, and our revenue was about $3 billion at the time, right? And so, I mean, essentially, this is a prized possession, right? Everybody wanted to do this.
Yeah.
And the reason for this, after we were acquired by Synopsys, is now you look at the problem of these multi-chip systems, multi-chip modules, 3D ICs, chiplets, right? These large complex systems having, like for example, the Cerebrus just did an IPO.
Yep.
There's 2.6 trillion transistors. These are complicated systems, right? So these have chips in them, chiplets in them. These chiplets are all connected together, 3D stacked dies and so on. And in the past, you would have to simulate them, design them individually. Okay, let me do the design of the chip with the EDA tools, and then, you want to do a simulation, the thermal simulation, the electromagnetic simulation, you have to do a separate tool. Now that we are part of the combined system, we can do the full multi-physics fusion analysis all together with the integrated tools.
Yeah.
That is why it is such an exciting combination, and that's why Synopsys paid so much money for it.